So ladies and gentlemen, today we are going to start graphing rational functions. So a rational function is a function that rule can be written as a ratio of two polynomials. The parent is 1 divided by x. This graph is called a hyperbola, which is a fun word to say. You should try it. Hyperbola, which has two separate sections called branches. Now your pattern for growing on this, let's give a little space here, over 1 and up what? Well, the way we get these patterns is we actually plug the numbers into the original function. So if I put 1 in here, it would be 1 divided by 1, which would be 1. Positive 1 would go up. Then if I go over 2, if I actually plug 2 in here, it would be 1 divided by 2, which would be positive, so it would go up, and it would be 1/2. Now, if I wanted something smaller than 1, I could plug 1/2 in. 1 divided by 1/2, remember dividing by a fraction is the same thing as multiplying by its reciprocal. So it would be 1 times 2, which would be 2. Now you can also put in stuff on the left, because that would just be putting in a negative number. So if I put 1 divided by -1, that would be -1. So it would go down. Same thing, if I put in 1/2, it would give me -2, so that would go down. If I put in 2, it would give me -1/2, so that would go down. So, when you start this, you're going from 0, 0 on the parent function. Other functions may have a different place to start, but so we would go right 1/2 up 2, right 1 up 1, and right 2 up 1/2. Left 2 down 1/2, left 1 down 1, and left 1/2 down 2. So it just kind of looks like that to start with. So I'm going to kind of do this in a weird order. The line x equals 0 is a vertical, no, didn't spell that correctly, vertical asymptote. And we've seen asymptotes before. Asymptotes are dashed lines. They can be vertical. They can also be horizontal. So this one, vertical asymptote through y equals 0. So you draw a dashed line up and down. Now, there also, the line y equals 0 is a horizontal asymptote, because let's talk about this for just a second. Okay, and put an open circle right there in the center. Okay, so the domain is x values. They're the x values, the numbers that you can put in. So what could you put in here and it would be okay? Well, almost any number. There's only one I can think of that we can't divide by. What number can you think of that we can't divide by? Hopefully you came up with 0. So the domain, or the numbers I can put in, are going to be all the real numbers except the vertical asymptote, which in this case is x equals 0. That's a terrible equal sign. Okay, so vertical asymptote would be at x equals 0. So if I can't put 0 in, then obviously I can't get 0 out. So my range, or the numbers that come out of this function, are going to also be all real numbers except now this one is horizontal asymptote, which happens to be at y equals 0. Okay? Now, when we graph these, we say that it has a black hole at 0, 0, or wherever its asymptotes cross. And that's not actually a hole in the graph. We will cover holes in graphs in 8.3, but not yet. So you do need to know that there is a hole. There is what we call a black hole, but that's just kind of air quotes. It's not actually a hole. So if you remember asymptotes, the graph can approach but never touch. Actually, it can cross a horizontal. Again, I can't spell vertical correctly today. Sorry. A vertical asymptote is a line that the graph approaches but never touches or crosses. It's drawn as a dashed line. Now, horizontal asymptote, the graph can cross, but it doesn't often, and in these ones it won't. So that one we can only say vertical on, even though horizontal asymptotes we're going to draw in as dashed lines also, but you do need to know that horizontal ones can be crossed and vertical ones never, ever, ever can. Okay, so that's what the parent function of a rational function looks like, 1 over x. Okay, it's called a hyperbola, and tomorrow we'll do non-hyperbolic graphs, so prepare yourself. So I also need to remind you that when you have a function, remember when we did quadratics, it was just x squared, but then we got all this other weird stuff in there, right? So remember this 2 out here would be a stretch or a compression. In here goes right and left, and after goes up and down. So you can see that we had a stretch of 2, we moved right 3, and up 4 were our shifts. So these same transformations apply in the reciprocal functions, they've just been moved around a little bit. Stretches, instead of being out front, will be in the numerator. Right and left goes to the denominator, and up and down goes after the fraction. So this will shift how? How would this plus 7 and minus 3 shift? Hopefully you know that plus 7 will go left 7, and minus 3 will make it go down 3. If this happens, anytime you have a shift, these will change the location of your black hole, which remember is not technically a hole, that's just its nickname, and the asymptotes. So it will change where your black hole is and also where your asymptotes are. It will also affect the domain and range. Okay, so if I had if my black hole is normally at 0, 0, and I moved it left 7 and down 3, my new black hole will now be at negative 7, negative 3. Which then will make my vertical asymptote, which is always x equals, vertical asymptote is always x equals, it will be x equals the x value of that new black hole. And the horizontal asymptote will be y equals the y value of the black hole. So they're always going to go together, black hole values and x and y for your vertical and horizontal asymptote. Okay, we also have on here a shift. So this up here is a vertical, those were the shifts. This is a stretch, vertical stretch of 5. Okay, when you have a stretch, this, will change the up and down part of the pattern. Remember, you multiply your up and down by whatever your stretch is. Okay, next, to find x-intercepts. To find x-intercepts always look like a number, then 0. To get your x-intercept, you will set your equation or your y value equal to 0 and solve. So if I use the same equation right here, my equation or another name for y is f of x. So I'll make that 0. So 0 equals 5 divided by x plus 7 minus 3. So let me use some different colors so you can kind of see what's going on here. So the first thing I need to do is move my 3. So it is subtracted, so I'll add it to both sides. So now I have 3 equals 5 divided by x plus 7. Now I need to get rid of that denominator. So how do you get rid of a denominator? You multiply both sides, because it's 5 divided by x plus 7, and the opposite of divided by is multiplied. So on this side, the denominator and what I multiplied by cancel. On this side, I have the distributive property. So that is going to be 3x plus 21 equals 5. Now I have room, so I'm going to move up here. But when I do that, I will need to subtract 21 from both sides because I'm solving for x. So 3x equals negative 16. Oops, I wanted to change color. Now you know we need to divide both sides by 3. So x equals negative 16 thirds. 16 and 3 can't both divide by anything. So my x-intercept is negative 16 thirds, comma, 0. To find the y-intercepts, you do the opposite. So to find the x-intercepts, we made the y equals 0, or the equation equals 0. To find y-intercepts, we are going to have 0 and then a number. So to find those, we will plug 0 in for our x. So same equation. Instead of f of x, I'm going to write y because it's another name. So y equals 5 divided by, make my x 0. 0 plus 7 minus 3. So I have 5 divided by 0 plus 7 is 7 minus 3. Now, this negative 3 is not a fraction, and the 5/7 is. So to make it a fraction, I'm going to put it over 1. Now remember, to combine fractions, we need to have the same denominator. Right now they don't have the same denominator. So what would I need to multiply by to make them have the same denominator? Well, they both would need to be multiplied by 7. So that would give this, it would stay 5/7 here, and that would be negative 21/7. Out of room again. So if I subtract those, I will get negative 16/7. So my y-intercept is 0, negative 16/7. 0 because I put 0 in for x, and negative 16/7 because that's what I got. So that's how you find x and y-intercepts. Now let's flip it over and put all of that together on two examples. So the first example, we have 2 divided by x minus 3 plus 4. So hopefully you are looking for transformations. Do you see any transformations? Well, let's start with this numerator. Is this 2 a transformation? Yes, it is. That 2 is a vertical stretch of 2. Okay, then you also know that the negative 3 and 4 are shifts. Well, you may not know that, but let me tell you, the negative 3 and the 4 are shifts. So which one would go left and right? Which one would go up and down? The one in the denominator goes left and right. So if it says minus, which way would you go? You would go left. And the one after the fraction is the up and down. So which way would you go, up or down? Hopefully you know that goes up 4. So remember your shifts, they affect your black hole. So if my black hole was at 0, 0, and I have now moved it left 3 and up 4, it's now at negative 3, 4. Oh, left 3, oh my gosh. I apologize. Minus in the denominator does the opposite of what it says, so it will not go left, it will go right. Right 3 and up 4, so this is a positive 3. At least I caught that before we started graphing. Okay, 1, 2, 3, 1, 2, 3, 4. So when you draw your black hole, it will be an open circle, and then it will shoot asymptotes up, down, right, and left. So pew pew. I don't know why asymptotes make laser noises in my head, but they do. Okay, so then our normal pattern for growing is left 1/2 and down 2, left 1, down 1, left 2, down 1/2, and same thing on the right side, except now up. Now, if we have a vertical stretch though, how does that vertical stretch affect this pattern? Hopefully you know that a vertical stretch is going to multiply all of these ups and downs by whatever that stretch is. So if the stretch were 3, I'd multiply them all by 3, but since it's 2, I'm multiplying them all by 2. So instead of going down 2, I'm going to go down 4, down 2, and down 1. And instead of going up 2, 1, and 1/2, I'm going to go up 4, 2, and 1. So when I graph, I'm going to graph these ups and downs with these rights and lefts. Okay, so I'm going to go from my black hole is where we start counting. Okay, we don't go from the origin, we start counting from your black hole. So I'm going to go 1/2 to the left and down 4, then 1 to the left and down 2, 2 to the left and down 1. Then drawing that branch, notice it's gotten a little bit further away from your asymptote to start with, but it still gets closer and closer. Right 1/2 up 1, 2, 3. Oh, ran out of graph. Just put it up there. Okay, and still draw in, get really close to that asymptote, but don't touch it or cross it. Okay, so now we can see where our vertical and horizontal asymptotes are. So what affects our vertical and horizontal asymptotes? The black hole does. Vertical asymptote is always going to be x equals, horizontal is always going to be y equals. And it's going to be the numbers of your black hole. So your x value is 3, your y value is 4. So those are your asymptotes. Then remember to do domain and range. Your domain is always the x's, so it is going to be all real numbers except the vertical asymptote, except the asymptote that has x with it. And the range is going to be all real numbers. It's y's, so it will be except the y. So all real numbers except 4 and all real numbers except 3. And you can see that as you go across and as you go up. We skipped over 3 and we skipped over 4. The y-intercept, to find the y-intercept, remember we put 0 in for x. So y equals 2 divided by 0 minus 3 plus 4. Y equals 2 divided by negative 3 plus 4. To change that 4 to have a denominator of 3, I'd put it over 1 and then multiply both by 3, so that would be plus 12 thirds. So negative 2 thirds plus 12 thirds would give me 10 thirds. So my y value is 10 thirds, and my x value was 0. Now to find the y-intercept, or the x-intercept, sorry, that's a little trickier. Put in 0 for your y. So 2 divided by x minus 3 plus 4. Now we need to get the x by itself. So we subtract 4. Negative 4 equals 2 divided by x minus 3. In order to cancel that denominator, I need to multiply both sides. So by it. So this side we would distribute. This side will cancel. So negative 4x plus 12 equals 2. Subtract 12. Negative 4x equals negative 10. Divide by negative 4. So I have x equals, since those are both negative, I can make it 10 fourths. Hopefully you notice that 10 and 4 both divide by 2. So I really have 5 halves. So my x-intercept is 5 halves 0. Last one. We've got something a little bit different on this one. So let's first talk about our shifts. We've got to shift which way. So looking at the denominator, it's a plus sign. So hopefully you know that even though, even though Mrs. Black messed up on the last one, hopefully you remember plus signs go left, minus signs go right. So since this is a plus sign, it will go left too. And out here is up and down. So this is going to shift down 3, which means that my black hole will be at negative 2, negative 3. And remember that shoots asymptotes up and down. Now we do have something here that we haven't seen before. We have a negative out front here. You haven't seen this negative out front yet on these because we haven't showed it to you. But do you remember what a negative out front does? Hopefully remember that when you have a negative out front, that is a reflection. So this is going to be a reflection. Which axis do you think it's going to go over? It goes over the x-axis. So all ups now go down, and any downs now go up. Okay? So our normal pattern for growing is right 1/2 up 2, right 1 up 1, and right 2 up 1/2. But now instead of up, all of those rights are going to point down. And our normal pattern for growing is left, all of those same numbers that we just went right, and down, but these will now go up. So as you can see, we're going to kind of flop stuff around here. So from my black hole, I start counting right 1/2, down 2, right 1, down 1, and right 2, down 1/2. So there's my first branch of my hyperbola. And left side, now I'm going to go up, and there's that branch of my hyperbola. Oops. Okay, so your vertical, horizontal asymptote, remember vertical is always x equals, horizontal is always y equals, and they are the points of your black hole, or the values of your black hole. Then your domain and range, domain is x's, so it will be all real numbers except x equals -2, whatever the asymptote is, and range also will be all real numbers except the y of -3. Now to do the y-intercept, we will put in 0 for our x, so y equals 1 divided by, negative. I'm going to move the negative up top. Negative 0 plus 2 minus 3. So y equals -1/2 minus 3. Okay, so this is a fraction and that is not. So to make it a fraction, I'd put it over 1. And then it needs a denominator of 2. So I'd have to multiply both top and bottom by 2. So -1/2 minus 6/2, which would give me -7/2. So my 0 was for x, so my y is -7/2. Then to do the x-intercepts, we put 0 in for y, so 0 equals -1 over x plus 2 minus 3. So first thing we do is add 3. 3 equals -1 divided by x plus 2. Multiply by both sides. Multiply both sides by that fraction denominator, by the fraction's denominator. And then the denominator over here cancels, and over on this left side where I have 3 times that, we will need to distribute. Ooh, that's really bad distributing. So we have 3x plus 6 equals -1. Subtract 6 from both sides. 3x equals -7. Divide by 3, so x equals -7/3. X values go first, so -7/3 goes first, y goes second. Now I didn't do this on the last one, and I really probably should have, so let's go back and look at this really quick. My y-intercept on this one is 0 and 10/3. 10/3 is 3 and 1/3. So if I look up here, on my y-axis, am I crossing at 3 and 3/3? That's pretty close. And my x-intercept is 5/2 0. That is 2.5. So am I crossing my x-axis at 2.5? Yep, pretty close. Same thing here. -7/2, that's going to be -3.5. Am I crossing my y-axis at negative 3.5? Yep. And my x is negative 7/3, so that would be negative 2 1/3. Am I crossing my x-axis at negative 2 1/3? Pretty close. So always double check that your y and x intercepts also match up with your graph. Good luck on this information.